In today's lesson, you're going to do 3 things. Number 1, familiarize yourself with scientific notation. Secondly, you'll be reminded of prefixes to use for numbers. And then thirdly, you'll have the opportunity to use those prefixes and those orders to look at some things which are huge and some things which are tiny. Now, the first part of the lesson is just to practice your ability to present numbers correctly. Now, in physics, whether you're dealing with problems or you're reading information, you will find that numbers must be expressed using scientific notation. Now, what is scientific notation? When you take a number in its decimal form and you present it using a 10 or a base 10 value to a power. Now, the number that you present must be between 1 and 10, no more than that. You can use a decimal place, so you could have 4.6 or 8.3, but not 14.6. It must be between 1 and 10. The actual position or the actual size of that value is then presented here in the power. So, for example, this monstrous number can be written as 5.6, a number between 1 and 10, times 10 to the minus 9. Why is it times 10 to the minus 9? Because we have 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. That's simple. So that's how you express a number in scientific notation. What I'd like you to do now is to have a go at the problems. Don't do all of them, particularly if this is something that you are comfortable with, right? So I'd like you to answer these questions, maybe like 3 or 4 from each question, and then check your answers. Part 2, prefixes. Once you have a number which is expressed in this form, you actually find, particularly when you're using units, that the base 10 to the power, or what we call, this is actually called an order number, right? So this order number can be expressed using a simple prefix. So for example, 10 to the 12 can be replaced by the symbol capital T, which represents terror. If we take this previous example, we have 5.6 times 10 to the minus 9. If you were using, for example, meters, this is a minute distance, 5.6 times 10 to the minus 9 meters, then we could replace the 10 to the minus 9 with nanometers. So in reality, we have 5.6 nanometers. These are the prefixes that you will be required to know for the IB. They're on this entire table is on the data booklet. However, it is definitely in your interest to memorize them because you don't want to be looking in the data booklet every time you have a numerical problem, right? Particularly for milli, which is times 10 to the minus 3, micro, which is 10 to the minus 6, nano begins with N, so it's easy to remember. It's 10 to the minus 9. And in terms of the large ones, kilo, 10 to the 3, mega, 10 to the 6. Mega's a million, right? So it's easy to remember. These are being used constantly, so please know those off by heart. Tera and giga tend to be used more in IT rather than anything else. If there is an area of physics which deals with numbers that are this large, those quantities tend to be replaced with actual special units, like the astronomical unit, for example, or the light year. Same with the really small ones. If something is this small, we're talking about subatomic quantities, and they tend to be replaced by their own constants, like the unified mass unit or the fundamental electron charge. So, the fundamental ones are these and these 3. Centi pops up occasionally, but it's quite rare. Now, the third thing you're going to do today is to look at orders of magnitude. Now, an order of magnitude is this number here. And when we're dealing with physical quantities, we tend to worry less about this number and more about this number. This is our order of magnitude. These are our orders of magnitude. And what's really unique about physics is that those orders of magnitude are huge in range for when we're studying different areas of the syllabus. So we'll be going to subatomic minus 10 to the minus 26 to looking at the absurdly large in astrophysics, which is 10 to the 42. Now, the IB requires you to have an understanding of orders of magnitude for masses and for lengths. And so for your assignment 1.14, you have to take some notes, okay, from the information that I'll give you. And there's kind of two parts to the work. Firstly, just basically taking down some data and writing down some orders of magnitude for different things, but then taking a bit of a guess about the order of magnitudes for a couple of other things. Now remember, when we're talking about the order of magnitude, we're not interested in the number. So the order of magnitude for a human being's height, you wouldn't write 1.2, that part of it, if you're 1.5 meters high or whatever. We're not interested in the 1.5 meters. We're interested in the times 10 only. So these questions would require you to think about just the order number. First, though, have a look at these resources. We've got link 1, size, scale of the universe. There's a really nice link there, so you can have a look at different sizes. Link 2, mass, and link 3, size. Have a look at these resources to complete the order of magnitude 1.14. Do not worry about the Prezi link to make a resource for mass. Okay, we can leave that for now. So the work that you have to do are these questions for 1.13 only, just these questions. And then for 1.14, you can do the whole assignment. Okay, so thank you very much and good luck.